this is the real Tom Rose. We have a pair of equations. They start out with 4 variables in them, and they tell you x is 2 and y is 1, and they ask you to find a and b. Well, we can solve this. Usually a and b are used by convention to represent constants, and x and y are used by convention to represent variables. So usually they tell you a and b and ask you to find x and y. Here they're doing the opposite. But there's nothing about the solution to this that changes at all. So just think of x and y as constants, which they tell you, and a and b as variables, and the solution is just a standard combination of linear equations. So let's plug in x and y to get the simplified version of this. So ax becomes 2x, by becomes 1y equals 8, and the other equation becomes 2b. Wait, I just put y up there, which is wrong. That should have been it was 2a plus y is 1, so this is 2a plus b equals 8. The second equation becomes x was 2, so that's 2b, plus y is 1, so that just becomes a equals 10. And let's reorder that. So it's a plus 2b equals 10. Just switching these terms to line things up. And we need to double something, so I'm going to double. Let's double this first one. I'll write it in a different color. We'll do 2 times the whole first equation. I'm going to write that down here. So I would get 4a plus 2b equals 16. Now I'm just going to look at these 2 equations, and I'm going to subtract them. So a minus 4a is 3a, 2b minus 2b is 0, and 10 minus 16 is negative 6. And I missed a negative right here, so this was a minus 4a is negative 3a equals negative 6. Let's divide both sides by negative 3, and you end up with a equals 2. So we know this can't be the answer, that can't be the answer, and this can't be the answer. But we need to figure out whether b is 3 or 4. So let's plug a is 2 back in to one of our equations. I'm going to plug it into this one. And what you end up with is 2 times 2 plus b equals 8. Or 4 plus b equals 8, or b must equal 4. So the correct answer is this one, the fourth one.